Hello everyone, welcome to the another video. In this video, we're gonna solve theory questions of 2019 exam papers. So the first question is explain sampling distribution of mean and what are its properties. So sampling distribution of mean is the probability distribution that describes the distribution of sample means obtained from all possible samples of a specific size drawn from a population. So the key characteristics of the sampling distribution of mean is the mean of the sampling distribution of the sample mean is equal to the population mean mu. This property is known as unbiasedness. And standard deviation of the sampling distribution, that is standard error. The standard deviation of the sampling distribution is called the standard error. It measures the variability of sample means around the population mean, and it is calculated as standard error is equals to standard deviation upon under root small n, that is sample mean. Sample size. Third is shape of the sampling distribution. So according to central limit theorem, as the sample size n increases, the shape of the sampling distribution of mean approaches a normal distribution regardless of the shape of population distribution, and this approximation of normality becomes more accurate when larger sample size, typically when n is larger than 30, is considered sufficient. Variability means the spread of the sampling distribution is less than that of population distribution. This means that the sample means will have a cluster closer to the population means than the individual observations from the population. Independence. The sample must be independent of each other. This means that the selection of one sample does not influence the other, which is essential for ensuring the sampling distribution behaves as expected. The second question is have to explain what is central limit theorem and its usefulness. So CLT is a fundamental statistical principle that states that the distribution of the sample mean approaches a normal distribution as the sample size increases regardless of the shape of the population distribution. Especially the CLT asserts that if you take sufficiently large random samples from a population with any shape, normal, skewed, etc., the distribution of the sample means will tend to be normal distribution. And second, this normal distribution will have a mean equal to the population mean mu and a standard deviation equal to the standard error. Now key points of the central limit theorem are sample size. Sample size 30 or more is considered sufficient for CLT. Independence, they must be independent to each other. Shape, it will be original the population distribution, making powerful tool in statics. CLT applies regardless of the original population shape, making it powerful tool in statics. Now the usefulness of central limit theorem are it's provided as a foundation for inferential statics, theoretical foundation for many statistical methods including hypothesis testing and confidence intervals. It allows statisticians to make inferences about the population parameters based on sample statics. Normal approximation, because sample means are approximately normal distributed, researchers can use normal probability distribution to estimate probabilities and make prediction about sample mean. Simplifies analysis. The CLT simplifies analysis by allowing statisticians to assume normality in many situations, which makes calculation easier. Robustness. The theorem's robustness means that it can be applied in variety of practical situations even when dealing with non-normal data. And sample size is sufficiently large. Quality control and sampling. In fields such as quality control, finance, and social sciences, the CLT allows for a specific effective sampling strategy and decision making. Facilitates estimation. The ability to use normal distribution to estimate confidence intervals for population means enable researchers and analysts to quantify uncertainty in their estimates. So first we have explained what is CLT, and the key points include sample size, independence, and shape. Usefulness include foundation of inferential statics, normal approximation, simplifies analysis, robustness, quality control and sampling, and facilitate estimations. Now the third question is what are the properties of good estimator? This has already been covered in my previous videos. And next is state the characteristics of T distribution. This question is also covered in my previous videos. You can refer to them. Now the next question is distinguish between lower tail and an upper tail in hypothesis testing and give examples also. So a lower tail test is used when the research hypothesis, alternative hypothesis, suggests that the parameter of interest is less than a specific value. This type of test evaluates whether observed data provides sufficient evidence to reject the null hypothesis in favor of the alternative hypothesis that specifies a decrease. An upper tail test is used when research hypothesis suggests that the parameter of interest is greater than a specific value. This type of test evaluates whether the observed data provides sufficient evidence to reject the null hypothesis in favor of the alternative hypothesis that specifies an increase. So here the null hypothesis HO, the population parameter is greater than or equal to a certain value. Alternative hypothesis is the population parameter is less than that value. In upper tail, the null hypothesis is the population parameter is less than or equal, and alternative is greater than the value. Example, suppose a manufacturer claims that the average life time of a light bulb is at least 1000 hours. A consumer group wants to test these claims because they believe in the bulb lasts less than that. So here the null hypothesis will be at least the mean lifetime is at least 1000 hours, and the alternative is less than 1000 hours. So if the consumer group collects a sample and calculates a mean lifetime significantly less than 1000 hours, they may reject the null hypothesis in favor of the alternative. And an example of upper tailed is consider a new drug that a pharmaceutical company claims increases the average recovery rate from an illness compared to an existing drug. A researcher wants to test if the new drug leads to a higher recovery rate. Here the null hypothesis will be 50% or less recovery rate, and alternative will be it is greater than 50%. So if researchers collect data from clinical trial and finds a significantly higher mean recovery rate, they may reject the null hypothesis in favor of alternative. Next is what is non-parametric test and what are the advantages and disadvantages. We had already covered its definition. Is a statistical test that do not assume a specific distribution of the data, unlike parametric tests which rely on assumption about the underlying population distribution as normal, and non-parametric tests can be used with data that do not meet these assumptions, and they are often used for ordinal data when a sample size is small. So common non-parametric tools are given here. Now the advantages of the parametric is there are fewer assumptions. It's less sensitive to outliers and skewed data which distort the result of parametric test. So robustness, applicability to ordinal data, simplicity, small sample sizes. So these are the advantages of non-parametric test. Disadvantages is it's less powerful as compared to parametric, limited informations, complexity in interpretation, and not always suitable for all data types, and rank-based method. Many non-parametric tests involves ranking the data, which can lead to loss of information regarding the actual values and variability within the data. The next question is, what is expected value of perfect information? Explain its importance in decision making. So the expected value of perfect information, EVPI, is a concept in decision theory that quantifies the value of having complete and perfect information before making a decision. It represents the maximum amount a decision maker would be willing to pay for the information that eliminates all uncertainty regarding the outcomes of their decision. So the calculation is done as expected value with perfect information minus expected value without perfect information. Now the importance of EVPI in decision making is guides investment in information, improve decision quality, identifies critical uncertainties, facilitate risk assessment, support strategic planning, enhance resource allocation, and encourage scenario analysis. So these are the importance of EVPI in decision making. That's all for this video. All the very best for your exams. Bye bye.